Hello, this is Miss Parks, and in this video, we are going to cover how to write equations of quadratic functions. So you're going to be given some information, and from that information, you will write the equation either in vertex form or in intercept form, depending on what's given to you. So for vertex form, you need to be given the vertex, and then you'll solve for A. So a vertex and a point, and then solve for A. And then for intercept form, you'll be given the x-intercepts and a point on the graph. And then you'll also solve for A, and I'll show you how to do that, of course. So for the very first question, this is obviously something that's in the shape of a parabola. We're given the vertex, so we will be writing the equation in y equals a times x minus h squared plus k, which is vertex form. So in order to do that, we need to vertex, and we need the a value. Well, we know the vertex in this problem here. We know the vertex for sure. The vertex is 50, 35. So that's here. That's in the wrong place. That's here. 50, 35. So I already know that the answer to my question is going to be something times x minus 50 squared plus 35. Okay. I also know that a is going to be negative because I can tell that the parabola is facing downward. And if the parabola is facing downward, then the a value is negative. We just need to figure out what it is. So this is a performer. This performer has been shot out of a cannon. And he's flying, and then the performer is going to land in a net over here. Okay? So the y value represents how high the performer is, and the x value stands for how far they have flown. Okay? So when they have flown 50 feet, they're at their highest point, which is 35 feet in the air. Now, we do know another point on the graph, which is what we need. So the point on the graph that we have, I'm going to use P for point, is 0, 15. Okay? But we also know that the vertex is at 50, 35. So we have 2 points. So what we're going to do is we're going to use those 2 points to solve for A. And then once we get A, we can fill that in to the formula. So let's just start there. So I'm going to write the equation y equals a times x minus h squared plus k. This is x, this is y, this is h, and this is k. For the purposes of solving for a, those are the variables that we're going to use. The vertex always gets the hk. The point is just a regular xy point that happens to be on the graph. So we're going to fill in every value into this equation except for a. So we have 15 is equal to a times 0 minus 50 squared plus 35. So we're filling in those values. We're going to solve this. So this is going to be negative 50 squared plus 35. Don't forget you have to use order of operations. Okay, I'm going to subtract 35. So now I have negative 20 equals a times negative 50 squared, which is 2,500. And then I'll divide both sides by 2,500. And you can write this as a fraction. If you reduce this as a fraction, it'd be negative 1 over 125 for A. Or you can use a decimal, which would be negative 0.008. Now, those are both exact answers. If your decimal wasn't exact, then it'd be better off using a fraction. And what I mean by not exact, it'd be something like 2/3, which is a rounded decimal. So either one of these is fine. I'm going to go ahead and use negative 1 over 125, and I'm going to fill that in to the a value. And now, the first part of this, write an equation of the parabola, has been done. The second part says how high is the net? Okay, so if we want to know how high the net is, then we need to figure out, because this is, the x is 90 where the net is. Okay, let me erase what's here so you can kind of see this. if you can see the numbers down here, so we have 0, 10, 20, 30, 40, 50, 60, 70, 80, and 90. And 90 is where the net is. And that line right there, the net, is at 90. And it looks like the height of the net is close to 20. Let me back out of this a little. It's just above 20 feet, but we don't know exactly where. And so we're going to plug in 90 into our equation so that we can know exactly where. Okay, so we have our equation here. So we're going to have, and for equation's sake, the decimal might be a little bit easier to use. Actually, it doesn't really matter. So we're going to be using x is equal to 90. So that's the distance, so that we can find what y is, which is the height. Okay, so negative 1 over 125 times 90, because we're using 90, minus 50 squared plus 35. And I'm going to go ahead and make that into a decimal since we already know what that is. This is going to be 40 squared plus 35, which is negative 0.008 times 1600 plus 35, which is negative 12.8 plus 35, which is 22.2 feet high. And that is the answer to the second question. Okay? And that's how you do that problem. So if you could try the next problem, that would be fantastic. All right, do the whole thing and then come back and check your answers here. All right. So again, I'm going to start by writing some information down. I know that my vertex is going to be 2530. And the point that's given, I'm going to just use a different color here, is 0, 20. So my equation is y equals a times x minus h squared plus k. This is hk, and the point P is your xy point. All right, so we have 20 equals a times 0 minus 25 squared plus 30. So 20 equals a times negative 25 squared plus 30. We'll subtract 30. Negative 10 is equal to a, and then I'm going to go ahead and square that times 625. And then you'll divide both sides by 625. Excuse me. And you will get negative 2 over 125. Okay, and if you wanted to, you can also say that that is negative 0.016. So my a value is negative 0. Not negative 0, excuse me. Negative 0.016. My vertex is, we already wrote that down, 25 over 30. So my equation is y is equal to a times x minus h squared plus k. You do not fill in the x and y into your final equation. You only fill in your vertex and your a value to get the equation. When they ask us for the height of the net here, we have to use whatever the x value is. You can almost tell right here that it's going to be 10. The thing is with graphs, we don't know if it's exactly 10. It could be close to 10, but not exactly 10. It could be 9.9 or 9.8 or 10.1. So we have to do the math. So x is equal to 60. So everything else in this problem stays the same except for the x, which becomes 60, so that we can solve this equation. So then we get that. So then y is equal to negative 0.016. 60, let me erase that. 60 minus 25 is 35 squared. Sorry about that. And then y is equal to negative 0.16 times 1225, which is negative 19.6, which is 10.4, which makes sense in the picture. And then we'll say that in this case, that's feet, and that's the answer to this question. Now, again, if you look at the picture at 60, okay, when we're at 60 here, you can see that it's close to 10, but we wouldn't be able to tell from the graph that it's 10.4. We can definitely tell from doing math or doing it mathematically that it's 10.4 feet and not exactly 10 feet. All right, so we're going to skip around a little bit, and we're going to go ahead and go to example 2. And this is going to be the last one that we're going to do here. In this case, we're not given a vertex, but we are given the two x-intercepts. So we have x-intercepts here, and those x-intercepts are at 4, or at 4, 0, and at 24, 0. And in this case, you could tell the a value is going to be positive. We need to figure this out. So we also have a secondary point that's given. So the x-intercepts are that. The point that's given is 0 and then 9.6. That's this point up here. Okay? Let me write that neater. So 0, 9.6. So these are my this is my xy point, and my x-intercepts are p and q. So the equation is y equals a times x minus p times x minus q in intercept form. If you go back and look at the top, that's what the equation is. So my xy point is x is 0 and y is 9.6. There are two x's in this problem, okay? And the a we don't know. The p is 4 and the q is 24. Okay, so remember in here we would use the opposite of those. So it's minus p and minus q, so it's minus 4 and minus 24. So to solve this problem, we just work this out using order operations. This is going to be negative 4. This will be negative 24 because 0 minus 4. 9.6 is equal to a times, and then negative 4 times negative 24 is 96. And if you divide both sides by 96, you'll get a is equal to 0.1, which is 1/10. And again, you can use whichever one of those you want. So the final equation, if you know that your if we fill this in, this meaning this guy, if we fill in the two x-intercepts and the a value, then you'll have the a value, I'm going to write 1/10, x minus 4, x minus 24. Okay? Now, they want to know what the coldest temperature is, and the coldest temperature, you can almost tell from here where it is. What we would have to do is find the middle point between the two intercepts. So if you take the two intercepts, which are 4 and 24, then those would be 4 plus 24. Okay, I'm up here now. Okay, 4 plus 24 divided by 2 is 28 divided by 2, which is 14. So at 14 would be the vertex. That would be the axis of symmetry. So when x is 14, you're going to get your coldest temperature. So 14 hours after midnight. So we'll do 1/10, and then x is 14. So y is equal to 1/10 of 14 minus 4, which is 10. So that's 1 right there. And 14 minus 24, which is negative 10. So that's negative 10. And that's the coldest. Negative 10 degrees, coldest temperature. And that would be, again, 14 hours after midnight. Okay, so we're going to skip the question B, and then we're going to go ahead and go to example 2. I just want you to write write the function. So that just means write the equation of this parabola that's here. And once again, they give you x-intercepts. So try to do the work on your own by pausing the video and come back to check your answers. So let's just go ahead and write the equation. Let's just start there. So we have x-intercepts, and those are at 6 and at 21. And then they give you an extra point, which is 0 and 6.3. So using this equation, y equals a times x minus h, no, x minus p. And x minus q. And again, this is your x, bear with me, this is your p and q, and this is your x and y in that formula. So what we have is we have 6.3 equals a, because we have to solve for a, 0 minus 6 and 0 minus 21. You have to use the x value of 0 twice. I don't want you to throw you off. So x is 0, so you have to use it here, and you have to use it here. You have to use it in 2 different places. All right, so then we have 6.3 is equal to a times negative 6 times negative 21. 6.3 is equal to a times 126. You'll divide both sides by 126, and you'll get 0.05 is equal to a. Since a is equal to 0.05 and we have the two x-intercepts, we're going to use this information to write the equation. Okay, so you need these two and this one to write your equation. So the equation will be y equals, you're going to fill in the a value, 0. I'll just go ahead, 0.05, you don't need the 0 in the front, x minus p, and x minus q, and q is 21. And it doesn't matter if 6 or 21 is first. So this is the equation, or the function that models this temperature. Remember, the x stands for the hours after midnight, and the y stands for the temperature in Celsius. So that's about it. You don't have to answer any other question. Oh, I guess we can answer this one. What is the coldest temperature? So the coldest temperature is the y value at the vertex. And so if you wanted to do that, you can plug that in. You can find the average between 6 and 21 divided by 2, which is 27 over 2, which is 13.5. And then you would have to plug 13.5 in for these x's. So if we did that, we would get y is equal to 0.05, 13.5 minus 6, 13.5 minus 21. So that would be 0.05. This would be 7.5. And this would be, let's see, I didn't work this one out ahead of time. So 13.5 minus 21. Which is negative 7.5. So 0.05 and then 7.5 times 7.5 negative is 56.25. And then times 0.05. Which is negative 2.8 degrees Celsius. In this case, is the coldest temperature. And that's it for this section.